Okay, so on to question number 2, which is numbered 3 here. That's okay. Uh, what value should you use for STK load to get a SysTick interrupt every 70 milliseconds on the Nucleo board? Recall that the Nucleo's clock is 4 megahertz. So the idea here is to use the equation time for the SysTick timer is equal to STK load plus 1 over the frequency of the clock. And that frequency of the clock in this case, because it's SysTick, that doesn't change. It's always that set value of 4 megahertz. So we'll plug in our values here. So we've got 70 milliseconds, which is 0.07 seconds, is equal to STK load plus 1 over 4 million hertz. Got enough zeros there? Yeah. And so we multiply 4 million times 0.07, and that gets us STK load plus 1 is equal to 280,000, and that means our STK load should be 279,999. And so that's our final answer there. Then part B, if you use the same value for STK load from part A, but ran that code on a newer microcontroller featuring a 500 megahertz Cortex M4 processor, how often would SysTick interrupts happen? So the idea here is that we're fixing STK load, and we are changing the clock speed to 500 megahertz now instead. So we're leaving STK load the same. So STK load plus 1 is going to be 280,000. And then we are going to have a 500 megahertz clock, which is 500 million hertz. And so at this point, it's just math, and we're going to have that time come out to either 0.56 milliseconds or 560 microseconds, whatever you prefer. And that's it for part B. Part C is more of a thought question. Assume that the SysTick timer has a similar configuration and control capabilities on the new microcontroller from Part B as the Nucleo board has. How would you write your code to have 70 millisecond interrupts on both processors? And the idea here is you have to take into account the clock speed of both processors, which may be difficult to do, but luckily there is a register that we have, which is STK calib, and we'd use STK calib to get 10 ms interrupts on both boards. So it gives you a count that tells you what the STK load value should be to get a 10 millisecond interrupts. And then we could either multiply that by 7, and that would get us the value. So we could either multiply by 7 to get 70 ms. Or if we were concerned about potentially not being able to fit that in a single STK load, we do have to remember that STK load is a 24-bit value, and that may have complications if the value we're trying to put in there, if that multiplied by 7 is larger than a 24-bit value. The other option would be to handle 7 SysTick interrupts. And both of those would probably get us, to the point that we could have this 10 millisecond interval, which is what we get from STK calib, and that would get us 70 milliseconds. So that's it for question 3.